Hi everyone. In today's challenge, we are going to solve this problem. The problem name is search a 2D matrix and the problem number is 74. Alright guys, so first of all, what we are going to do, we are going to clearly understand the problem statement. So first of all, we will understand the problem statement. After understanding the problem statement, then only we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem. So after understanding the logic part, then we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution, which I'm gonna write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution, right? Now guys, let's see what this problem says. So let's understand the problem statement. So guys, problem says you are given an m cross n integer matrix with the following two properties. So first of all, it is clear that we are given one input, that is nothing but, let me write here input, that is nothing but we can say matrix. Matrix is nothing but 2D array, right? Fine. And this matrix has two properties. The first property is nothing but each row is sorted in non-decreasing order. So you can see in the example one, we have this image. You can see here, this is first row, this is second row, this is third row, right? And these all rows are sorted in non-decreasing order. You can see 3 is greater than 1, 5 is greater than 3, 7 is greater than 5, right? And similar for this row, similar for this row. That means that all the rows in our matrix is going to be sorted in non-decreasing order. Fine. The second property is nothing but the first integer of each row is greater than the last integer of previous row. So this is our first integer. Let's say this is let's consider this particular row, right? So in this row, you can see the first integer is 10, right? And it is greater than the last integer of the previous row. This is the previous row. So we can say here you can see 7. So 10 is greater than 7. Similarly for this row, 23 is greater than 20, right? It makes sense. That means that what first integer of a row is always be greater than the last integer of the previous row. Fine. Given an integer target, return true if target is in matrix or false otherwise. Simple thing guys. We are given second input. This is our second input. That is nothing but integer only, right? So we are given one more integer and we have to check whether that integer is present in 2D array or not. If that integer is present in our matrix, means 2D array, that means we have to return true, otherwise we have to return false. Right? It makes sense, right? So we have understood the problem statement. And guys, you must write a solution in big of log of m cross and time complexity. Fine, it makes sense, right? So we have understood the problem statement. We are given one 2D array or we can matrix, and we are also given one integer. We have to find whether this integer is present in our 2D array or matrix or not, right? If it is present, so return true, otherwise return false. So let's see the example one. In the example one, we have this array, right? So you can see this image. So what we have to do, we have to find nothing but 3, whether 3 is present or not. You can see we have 3 in this array, so we are returning a true. So here just we are understanding the problem statement, not logic, right? How this is working, we will see later. But for now, you have to understood the problem statement. In the second example, also we can see we have to find 13, right, in this matrix, and 13 is not present in this matrix. So we are what we are going to do, we are going to simply return false. You can see output as well false. And these are the constraints. I hope you have seen this one. So guys, we have seen the problem statement, right? Simple thing, right? Now let's see the logic part, how we can find this one, right? How we can find a particular integer from a 2D array, right? So let me write a logic, and simply I'm going to consider this example one. If you understood this example one with the logic part, then definitely you can easily solve all other example as well, right? So let's see how we can find 3 from this particular matrix. See guys, there's one algorithm called binary search, right? I hope you have learned about that particular algorithm as well. You have at least understood somewhere listened to that algorithm as well. So that algorithm work on a sorted or we can say ordered data, right? Binary search is used to find data in a sorted or we can say ordered data, right? So here, let me just write a binary search. What is binary search? If you don't know about binary search, just do a little research about it. It is a very easy algorithm, right? You must have heard this problem, this algorithm from somewhere, definitely, right? So what this binary search algorithm do? It basically used to find a data. It basically used to find a data from a set of some space, or we can say array, right? It also used to find a data from integer array, right? Whether that data is present or not in an efficient time. That is time is nothing but big of log of and time complexity, right? So it used to find data from such space where data is in ordered in big of log of and time complexity, right? But we cannot use a binary search directly here. Like binary search is used for us, we can say simple 1D array, right? For now, it may be used for 2D array, 3D array, but for now, what I'm saying that binary search basically what we have heard for now, that we can use a binary search in a 1D array where data is always ordered. So we can use 0 here, search space, 5 here, search space, and try to find out binary search. Keep decrementing the left side. Either we are moving to the left side or right side, right? That makes sense, right? So this is nothing but a simple binary search. Now, how we can use a binary search? Definitely binary search can be used in 2D array as well, right? But how we can use it in this 2D array binary search? First of all, we need to check whether this is in ordered or not. You can see this matrix is in ordered. Why? Because you can see this is in sorted order. We can say 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. You can see it is always in a no decreasing order. If we gonna consider like this way, first of all this row, then say this row, then this row, right? So we can say our data is in order. So can we use now binary search? Definitely we can use a binary search over here. But how we can use a binary search here? Let's see that part. So what I'm going to do, I'm going to simply say, first of all, find the total rows, right? Total rows is nothing but we can say rows is nothing but there are 3 rows. Total column is nothing but we can say 4 column, right? Now what I'm going to do, I'm going to say I have to define a search space, right? Low and high. Here my binary search algorithm going to work. So my low is going to be nothing but what? Low is going to be always 0, right? And high is going to be total number of element we have in our, or we can say total number of space, length of space. So here you can see the space is going to be, this is 4, this is 4, this is 4. Let me 4 into 3, 12, right? 12 minus 1 because index goes from 0 to 11. Fine, I hope it makes sense. So now we have defined our space. So what I can say, I can say simply, this is my space, this is 0 index, 1 2 3 4 5 6 7 8 9 10 11. So this is nothing but our space, right? So we can say this is nothing but our space. So we have defined our space. So what I'm going to do, I'm going to say, okay, you have this low is standing over here, high is standing over here, so you have to find mid. So mid is going to be nothing but low plus high divided by 2, 0 plus 11 divided by 2, that is nothing but integer division. So we are going to say 5. So currently my mid is here. Fine. So my mid is here. So I'm going to check whether this mid is greater than my target or not. If it is greater than target, then we are going to move to the left side. If it is smaller than target, so move to the right side. But if it is equal, so return directly true. It makes sense, right? So how we can say this 5 is storing what value? Earlier what we used to do, we have a 1D array, right? So we directly search from our array of mid, is it equal to target or not, right? Because this is a 1D array, but here we don't have 1D array, we need a row and column, right? How we can find a row and column from this 5? So we can find a row column by just using a simple logic, right? Row is going to be, current row is going to be anything but what? This mid is nothing but 5, right? Mid divided by column. Columns nothing but total number of column we have, right? So divide is nothing but integer division, right? So if you say mid is nothing but we can say 5, right? And columns is nothing but 4. We have already calculated 4. There are total 4 columns. So mid divided by means 5 divided by 4 is nothing but we can say 1. So that definitely shows that this 5 is always lying in the first, this particular row, first indexes row, right? Fine. Now find the current column. So current column we can use mid modulus columns. But we this do mid modulus column is nothing but tell us that which column currently this 5 index lie, right? So 5 modulus 4 is nothing but 1 only, right? So this is nothing but we can say the first column is nothing but first column. So you can say first row, first index is row, first index is column is nothing but 11. So is our 11 is greater than is equal to 3? No, it is not equal to 3. That means we are not going to return true for now. Is it smaller greater than 3? Yes, it is greater than 3. 11 is greater than 3. So where we are going to move? We are going to move to the left side. So we are going to say now high is going to be here, right? So we high is not high. So now again we are going to find a mid here. So mid, if you'll find, you will say 0 plus 4 divided by 2, mid is going to be at 2. So for 2, what is your going to be? 2 divided by 4 is nothing but 0. 2 modulus 4 is nothing but we can say 2. So 0 row and second column. Let me move all these things now. So 0 row and second column. This is nothing but 5, right? So 5 is also greater than 3. So we are going to move again to the left side. So we can say now high is nothing but at 1. Right? I hope it makes sense. So we are going to say at 1. So 0 and 1. So what is going to be mid? So 0 plus 1 is nothing but 0. I hope it makes sense. Mid is going to be 0 plus 1 divided by 2. So what you are going to get? 1 divided by 2. This is next one we can say 0. So 0 4. Here we are going to get 0 0. So here also we are going to say 0. So 0 we are going to get 0 0 and index, this index. So this is the index. So you can say this is greater than our, we can say our, which we are trying to find 3, right? So all right, so it is greater than 3. So we are going to say our mid is going to be not right there. Our low is going to be at 1 index only, right? So we have moved to the right side because it is great. 1 is nothing but smaller than our target. Right, so we move to the right side. So now we move to the right side. Now low is also 1, high is also 1. So we can say fine, low is also 1, high is also 1. So low plus high divided by 2. Again, 1 plus 1 divided by 2 is nothing but 1 only, right? So we can say 1. 1 divided by 4 is nothing but we can say 0 again. 1 modulus 4 is nothing but 1. So 0, 1. So 0 row, first column. 0 row is nothing but this one, and first column is nothing but this one. So is 3 is equal to our target? Yes, 3 is equal to 3. So return true. So we can simply return here 2, and you can see output as well 2. So this is the simple algorithm we are going to use. But if it is also not the case, then it will gonna, low will gonna always be greater than high. There we are going to return false, right? So I hope it makes sense, right? So we are simply going to use a binary search over here, nothing else. So just the tricky part was here, that how we can find a row and column from a given mid, right? That we have seen, mid divided by column is gonna give us current row, and mid modulus column is gonna give us current column. Now guys, let's move to the implementation part and let's see how we can implement this one, right? So guys, I'm first of all with Python, so I'm gonna quickly say my total rows, right? So total rows is gonna be length of matrix and total columns is going to be the length of matrix of 0, right? As we have already seen construct, there will be at least one index, right? You can see matrix dot length comma n is going to be always at least greater than or equal to 1. It will not be 0, so we can directly use matrix of 0, right? Fine. Once we found the rows and column, we are going to use a low and high space. Low is going to be nothing but equal to 0, and high is going to be nothing but and rows columns minus 1, which is nothing but we can say. In the first example, it's going to be 12, 12 minus 1 11, and in the next example, it's going to be rows into column minus 1. Fine. Now we are going to use a while low is less than equal to high. So what we are going to do here, we're going to find a mid. Low plus high divided by 2, so we can say directly say like 1. Here 1 I have done because I'm using bitwise operator, but you can directly so divide by 2 as well, right? Once we found a mid, we are going to check current row and current column. Current row is going to be nothing but mid divided by columns, and current column is going to be nothing mid modulus columns. Once we found a current row and current column, we are going to say find if matrix of current row and current column is equal to target, so we are going to directly return true. But if it is not the case, if matrix of current row and current column is greater than target, so we can simply move to the left side. So we can say high is going to be mid minus 1. But if it is also not the case, that means it is going to move to the left side. So we can say low is going to be mid plus 1. At the end, we are going to say return false. So you can see guys, it's going to return a false. So that means let's see whether it's getting past all the test case or not, because else we are seeing a colon. So we have to forget to use colon. Now let's see. So definitely guys, it should work, right? Because we are simply using a binary search over here. You can see both the test case pass. So let's try to submit this code. It definitely going to pass all the test cases as well, I believe. Because it's a simple problem, right? You can see guys, it's successfully got submitted. So now let's move to the next programming language, which is nothing but we can say C++. So let's quickly move to the C++. And here what we're going to simply say find out the rows. So we can say matrix dot size. In columns, which is going to be matrix of 0 dot size. So now once we found the rows and columns, then what we are going to do, we are going to simply say find out the range int low, which is going to be equal to 0, int high, which is going to be nothing but rows into columns, that means columns minus 1, right? So once we found our range as well, then what we are going to do, we are going to simply say while low is less than equal to high, find out the mid. So mid is going to be nothing but low plus high divided by 2, and divided by 2 you can do like bitwise operator 1, right? So once we found our mid, then what we are going to do, we are going to simply check, right, whether this mid is ever equal to target. First of all, we have to find a rows and column with this mid. So current row is going to be nothing but mid integer division divided by total number of columns, right? And in current column is going to be nothing but mid modulus of columns. So once we found a current row and current column, then we are going to check. First of all, check with what is that. If matrix of this current row and current column is equal to our target, so simply we are going to say return true. So this will return true. But if it is not equal to target, so what we are going to say, we are going to say simply matrix of current row and current row column is greater than target. Check whether it is greater than target. If it is greater than target, then we have to move to the left side. So we are going to simply say high should be equal to mid minus 1, right? But if it's also not greater than target, so you can simply say guys, if it is not equal to target, if it is not greater than target, so definitely it will be less than target. So we are going to say else move your low is equal to mid plus 1, that is we can say move to the right side, right? Fine. And guys, after this while loop, that means if we could not find our element in our matrix, so we are going to simply say return false. Let's see whether it's working fine or not. So I believe guys it should work, right? Let's see. You can see guys, it's giving an error because we haven't put a semicolon here. Okay, now let's see. Okay, and you can see guys, it successfully got past all the test cases. Selected to submit this code as well, and I believe guys it will also gonna submit. Let's see. And it's taking a time, but yeah, you can see guys, it successfully got submitted. Now let's move to the next programming language, which is nothing but we can say Java. And in the Java, first of all, we are going to calculate what rows. So into rows, total rows is nothing but matrix dot size. Not size you can use a length here. And in columns is going to be nothing but matrix dot length, but you have to use a 0, right? And let me write a length. What happened to me, I don't know. Fine. Once we found the rows and column, we are going to find a space, our search space, which is row is equal to 0, and high is going to be nothing but rows into column minus 1, right? So once we found our space as well, then we are going to use a binary search while low is less than equal to high. You're going to say find out the mid, which is going to be low plus high divided by 2, and you can do like this. Once we found our mid, then we are going to see if our first of all found a row and column, right, with respect to this mid, what is row and what is column. So current row is going to be nothing but mid divided by columns, right? And you can see after that we can use simple current column, which is going to be mid modulus column, right? Once we found our current row and current column, we are going to say find if matrix of this current row and current column is equal to target. So we can say simply return true. But if it is not the case, if matrix of current row and current column is greater than target, so what you can say return directly. What you are going to return? You are going to say not return. You are going to move to the left side because it is greater than target. That means our number should be present on the left side. So if we're moving the left side, we can say high should be mid minus 1. But if it is not also greater than target, that means it must be, it always going to be less than target, right? If it is not equal to target and not greater than target, so it always be less than target. So we can say else low should be mid plus 1, which means that we'll move to the right side if it is smaller than target, right? Fine. After this while loop, we could not able to find our answer in our matrix, so we can say directly return false. Let's see whether this working fine or not. And I hope guys it should work, right? Let's see. It's taking a time. You can see guys, it's passed both the test case. Let's try to submit this code, and definitely it will also want to submit, right? Because I don't think we have done any mistake. Yeah, you can see that it's successfully got accepted. Now let's move to the next programming language, which is nothing but JavaScript. And this is I really have a fear with this programming language. Fine. So what first of all, what we are going to do? We are going to select rows. Total rows is going to be nothing but matrix dot size. You cannot use size. You can use the length. And let rows columns is going to be nothing but matrix dot. We can say matrix of 0 dot length, right? Once you find all these things, then what you're going to do, you're going to find out the range. So low is going to be what we can say equal to 0, high is going to be what we can say rows into columns minus 1. Once we found low and high, then what we are going to do, we're going to say while low is less than equal to high, so you can say find a mid. Let mid is going to be what, low plus high divided by 2. Fine. Once we found a mid, first of all find a current row, which is going to be mid divided by columns. Okay, and find out the current column, which is nothing but mid modulus column. Fine. Once we found a current row and current column, we are going to see if matrix of current row and current column is equal to target. So directly return true. But if it is greater than target, it is not equal to target and it is greater than target. Here I have to use matrix, not metric. Fine. And if it is greater than target, that means we have to move to the left side. So we can simply say high should be equal to mid minus 1. And also if it is not greater than target, it is not equal to target, that means it will always be less than target. So we can say move to the right side. So right side you can use low is equal to mid minus 1. And then we can simply return false if we could not able to find our target in our matrix, right? Fine. And it will give an error. Why? Because mid divided by columns, it's going to give us float value, right? For converting integer, we can use mat.float. Fine. Now let's see whether this can find or not. And I hope guys it should work, right? Let's see. But first test case is failed, so the issue is nothing but we got false, right? Why it is the case? So if it is greater than target, we are seeing mid high minus 1, current row current column, current row current column, as your row is equal to mid minus 1. So it is the mistake, right? Mid minus 1 node, it should be mid plus 1, right? We're moving to the right side. Now let's see. But still we are getting a false. Fine. So again we see matrix total length length. The mistake in the first line only, right? Let's see. And you can see guys both the test case passed. So let's try to submit this code. And you can see guys it also successfully got submitted, right? So we have done the implementation in Python, C++, Java and JavaScript programming language. I hope you understood the implementation part. If you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.